just give me the thumbs up if you can hear me okay. Coolio. Thanks everyone. So does anyone have any questions to ask before we get into today's content? Any questions so far on the topics we've covered? You know, if you got any questions, just, you know, feel free to ask us. You know, Harshan and I are here to help you guys out with anything that you might have. Today we're going to get into capital budgeting, and you'll find that we're going to introduce a lot of different topics that, especially formulae and calculations, that will be of relevance to us. So we'll be coming back to those quite a lot. I do want to share with you on your formula sheet, you do have a section called capital budgeting. So I do encourage everybody, if you can see where my cursor is, the top right section of your formula sheet on the first page is your capital budgeting section. And you're going to find that we do have a few formulae to get through. Now we're going to work slowly through all the questions. If there's anything you're not sure about, just feel free to ask us. But you are going to find that the NPV, or the net present value, is going to be one of the topics that we keep coming back to. And everything else from there, you know, the internal rate of return, the profitability index, the equivalent value, and so forth, stems from the net present value calculation. So pretty much the top bit of the first page of your formula sheet is what we will be focusing on mostly today. So let's get into the topic for today. We do have a handful of multiple choice questions to get through. Now, just a small recap. Last week, if we can all remember, there were two major asset classes that we talked about, and those were bonds and also shares. And you might recall that, you know, when we use bonds, we use a variety of annuity functions, and when we use shares, we use a variety of perpetuity functions. Okay, today we're going to take that concept slightly further, and we're going to focus on net present value or capital budgeting techniques. Net present value is one of those computational techniques, but we do have a range of other ones that we're going to look at. We're going to look at different types of projects, types of cash flows, and also how do we assess projects that have a different lifeline. So, you know, you might have a project that goes for 2 years, and then you've got a project that goes for 6 years. How do you equate the two? And we're going to introduce one of the more complex techniques, the extension of the NPV formula, to assess like-for-like projects. So everyone, let's jump onto the poll everywhere. I've delivered the first question just while we waited on the class to begin. Who wants to have a go at the first one? When comparing two projects of different life, why do we compute the equivalent annuity? And I think most of you would have gotten this one correct already. It's because, you know, you want to have projects that you can compare like for like. So comparing them based on cost per value basis per period is what allows us, is what equivalent annual annuity lets us do. So option B here is the correct one. So you'll find that if we've got a project that goes for 2 years and then got a project that goes for, say, 3 years, allowing us to calculate the payment amount per year, per period, will then help us understand, well, hold on, you know, the 2-year one, while the overall NPV might be lower, the naive NPV or the first NPV that we assess, when you look at it per period, per year, the shorter one sometimes can actually give you more value. You can actually make more money per year on the shorter project than on a longer one. Okay, so the equivalent annual annuity, okay, that's effectively what it does. It equates annual amounts to allow us to compare different topics. Yeah, sure. Can you not see the link? Hold on one sec. Can you not? if I share the screen, can you? Can you click on that? Does it take you to the? Okay, cool. All right, let's have a look at the first one. Which of the following statements is false? So I'm glad that you selected option C. That one is actually true, and you'll find we'll go through some of the calculations in a second. But in cases where the IRR rule, the internal rate of return rule, differs from the net present value, we generally go with the net present value as a rule of thumb. So option C there is actually true. And the one that we want here is option B. So when the net present value is usually consistent with the IRR investment rule, and you'll find that when you do when we apply different discount rates for the net present value, sometimes those two decision rules will clash. So option C there is the correct one. It's option B that is false of the four that are given. Let's have a look at the next one.
Right. Hi, Brian. I think now you are sharing the slides, not PowerPoint. Yeah, we can only see the slides right
Am
now.
I? Oh, sorry, guys.
Okay.
One sec. Thank you for that. I didn't realize that. I think I was sharing the screen and then I flipped to the slides when I got asked the question. Can you guys all see that?
Yeah, it works now.
All right. Question 4. Again, which one of those is false? So profitability index. So we've got the correct answer there in C. The profitability index can be easily adopted when we determine the correct investment decision with multiple resource constraints existing. So we are going to look at the question here on profitability index, and you'll find that when we assess the profitability index, looking at your formula sheet, we use the net present value of each project, and we divide the resources consumed by the net present value to get the right answer. All right. What about the net present profile, the net present value profile graph? What do we graph here? So what's on our y-axis versus x-axis? Yep, we've got the MPV and we've got a range of discount rates. So you'll find that on the x-axis, we'll plot the discount rates, and on the y-axis, we'll plot the net present value. So in one of the questions again today, we're going to look at how we plot those. We take the difference in the cash flows between two projects, and then we take the internal rate of return of the difference. All right. Let's quickly do a survey on the following. So we've been asked to do a survey on the tutorial 4. So I'm going to deliver it and give you guys, say, 3 minutes to have a go at answering the following survey. Let me know if you can see it on your end. All right, we've got almost 20 people responding already. Well done, guys. I'm going to keep the survey open so you can probably jump back in during the break as well if you want to have a go at anything else. Let's have a look at what we will be covering today. Does anyone have any questions before we get into the content and the questions? Now, remember, the focus of today's topic will be on capital budgeting, and I'm just going to put that here so that we keep coming back to that terminology, capital budgeting. And you might recall from our sort of assets and liabilities balance sheet that when we talk about capital budgeting, we are focusing on the asset side of our balance sheet equation. So typically we look at what's called the long-term capital assets. And you might be familiar with the terminology short-term, long-term. Short-term generally refers to anything that's less than a year. Long-term generally refers to anything that's more than a year. And if we have a look at the following, some of the key techniques that we're going to be using are the payback period. Okay, so you might have an example where, let's say you want to open up a restaurant and you know that the cost of the restaurant is, you know, whatever, 100,000, and then you forecast the cash flows to be, you know, whatever you want to think of every year for the next X number of years. Typically, when you approach the payback method, you want to come up with a date to recoup the initial $100,000 that you invested in that restaurant. So you might say, hey, you know what? I want to get my money back in the next 3 years. Like naturally, I've got a large capital investment initially. How many years will it take me to get that money back? So that's an example of a payback period technique. We've got an internal rate of return assessment where we make the net present value to zero. So at what discount rate will the cash flows equate to zero? So the investment and the cash flows that we receive are equal to one another. And then lastly, we've got the net present value. So this one is really looks at all the benefits, all the cash flows we make each year versus initial cost usually that we invest in the project. Now, typically a rule of thumb when it comes to net present value is if it is greater than zero, we would accept the project, okay? And if it's less than zero, we would reject the project, okay? We will also look at the profitability index, the net present value versus the resources invested, and then also the EAA, or the equivalent annual annuity. So this one looks at projects of different lives, and then says, hey, you know what do we make this year? and the next year, and so on and so forth. So for every year of the project's life, what do we make in terms of cash flows? And then we can compare, well, a 2-year project makes $2,000 a year, a 4-year project makes 1,500, right? And then in that, that way, we know that the 2-year project gives us more per year versus a 4-year project, for example. So those are some of the methods that we are going to apply through the questions that we do. So this is some of the criteria that we already discussed. How do we apply the maths that we have? So you can probably zoom in on this one, and I would probably kind of have this stored somewhere. Net present value greater than 0, we would accept. The internal rate of return greater than the discount rate, we would accept. And then payback period, if it's less than the cutoff period, then you would also accept that project. And keep in mind that this is very much an arbitrary number. The cutoff period could be anything. Like you as the potential restaurant owner, you can say, hey, you know what, I want my money back in 2 years. If I don't get it, well, maybe I won't sort of pursue the investment and so on. So those are some of the things that we're going to look at and work through each of the questions in today's class. So let's have a look. So once again, let's try and stick with the sort of timeline, the formula, and so on, the numbers and the result approach that we followed. So the 4-step approach that we followed so far, we want to try and do this time around as well. Can you use an Excel? Yeah, you can. Or do we have these? No, Excel's fine. So your mid-sem test is going to be similar to your exam in the sense that it's going to be done through an e-assessment platform, and you will be given an Excel spreadsheet. So effectively, you'll do it on your computer. Multiple choice or short answers. I don't know. I think it's a combination of the two. From what I remember, you're going to have part A and part B. So there will be multiple choice, there will be short answer. It's going to be a mix of the two, and there could be some longer answers as well. So once we get to we'll talk about more about the mid-sem closer to it. So which is in 2 weeks' time. Any other questions? So we did have a slide overview on page in week 1 about the mid-sem. So you might be able to refer to that as well, but from memory, it's going to be a combination of those. Write a formula in the answer. Well, look, I mean, if it's a multiple choice question, no. I mean, it depends on the question, but I generally encourage people to show all the working steps where possible. So especially with longer answers. Like for example, if you got a spreadsheet and you're given a capital budgeting question, even if you have no idea what's going on, at least try and give us an MPV formula with some sort of syntax and some sort of input. So yeah, short answer is yes. All right, let's get into this one. So let's have a look at the following. The cash flow for the 2 projects are shown above. The cost of capital is 9.5%. If an investor decides to take the project with a payback period of 2 years or less, which of those would he consider? So let's think about it for a second. So we've got the first investment, which has a $15,000 in year 0 capital cash flow commitment, and then we've got each year we make $7,000. Okay, so each year we make $7,000. We also got a second investment, which has a cash investment of $18,000, and then each year it makes 12, and then 2, and then 2, and then 2, and then 2. Okay, so a range of different cash flows. Now the question here is asking us, well, if the payback period that we select the cutoff period is less or equal to 2 years, that's what the question is telling us. 2 years or less, that's the payback period. Which of those would you want to go with? Now, sometimes these questions you can sort of just do it without any maths, because a payback period is pretty much asking, well, how many years will it take us to get our money back? Okay, so we've got one answer already, investment A. Okay, why is that? You get your money back faster. That's cool, but let's have a look at firstly, what are we trying to calculate here? Like, how many years will it take us to get our money back with the first investment, right? So we initially have 15,000 invested. It takes us 1 year to get 7,000, and then it takes us another year to get 14,000. We are still $1,000 short, right? So far we've got 14,000 here in the first 2 years. That's 14,000. But we're still $1,000 short, right? So if we look at the option A, we've got 2 years to give us 15,000, and then we've got the remainder of 1,000. That's the remainder versus what we received in year 3. So how many years does it take us to get our money back for option A? For option A. Yeah, 2.14. Okay, so it takes us 2.14 years to get our money back. So if we look at the remainder here, it actually is between year 2 and year 3 that we make $15,000. Because we go, well, we make 7,000 in year 1. We make 7,000 year 2, well, that's 14,000. So that's 2 years. But we know that it has to be more than 2 years because we still have $1,000, the remainder of 1,000 that's missing. So what is the proportion of year 3 that we need to get to the payback amount? And that's 2.14 years. Now, you said in the chat, and that's cool, investment A you would select. Well, hold on, let's pause there for a second. What is our cutoff period here? The cutoff period is 2 years, but option A takes us 2.14 years. So the question is, do you select something that takes you longer than you initially? Yeah, neither, exactly. So option A we can discard. Let's have a look at option B quickly. We invest 18,000, right? We invest 18,000. So let's just quickly, without any math, let's just go through the years. How many years will it take us to get 18,000 back for option B? 4, exactly. So we make 12 in year 1. We make 2 in year 2, so that's 14. We make 2 in year 3, that's 16, and we make another 2 in year 4, that's 18. So it takes us 4 years to recoup the initial for 18,000. So once again, the cutoff is 2 years. So both investments, or neither of the investments, if you like, is what we will go with, because both of them are actually greater than the 2 years that the cutoff period is. Does that make sense, everybody? So you can almost ignore the formula here and just go, well, go year by year and just add them up. And in both cases, option A, it's 2.14 years. Well, that's more than 2 years. And option B, it's 4 years. Well, once again, that's more than 2 years. So in both cases, we would decline the investment. Any questions? Now let's have a look at the next question. Burke Incorporated is considering purchasing Small Limited. The acquisition will cost 190,000, okay? But it would increase the cash flow by 30,000 per year for the foreseeable future. If the cost of capital is 15, should you go ahead with the acquisition? Now I want to pause there for a second. What do we mean by foreseeable future? What mathematical function do we apply here? How many years is that? Like how do I put a timeline around this? So when we talk about a terminology called foreseeable future, typically there's no fixed timeline. So we can assume that the regular perpetuity function is what we can apply to the calculation of the present value of the cash flows. Okay? So if we think about it, we've got our cost or the outflow, which is 190,000, right? And it tells us in the question, your cost is 190,000, right? And we've got our benefit of $30,000. And it tells us in the question, you would increase your cash flow by $30,000 per year into the foreseeable future. So in other words, we can apply the perpetuity formula, the 15% is the discount rate, to calculate, well, if into the foreseeable future 30,000 is what we make every year, what is the present value of those payments that we receive today? So this is our cost, okay? That's the cost. Now remember, why do we not discount the cost? Because the cost happens today. So the in time value money terms, the present value, the net present value is happening at time zero in this case. And this is our cash flow zero, net cash flow zero. So there's no need to be discounting it because it's happening right now. We're going to invest $190,000 today. And then from next year onwards, so from year 1, year 2, year 3, year 4, year 5, whatever, we receive $30,000. So mathematically, all we have to do is discount the cash flows that are happening from this year onwards, from today onwards, from time zero onwards. So what do we get and do we accept? Now, this type of question, just another note, if you do this in a spreadsheet in Excel, literally just punch in negative 190, 30 divided by 15 and sum them up. Like you can do a formula if you want, but technically it's such a simple amount, you can just literally just use the numbers as you see them on paper. So $10,000 is what the net present value of the following investment is. Accept, reject, why? Yep. So naturally, we would accept the project. Net present value is greater than zero. So in that case, we can just go ahead and accept the project. Now you might have come across independent versus mutually exclusive projects. Again, that's some of the terminology when we introduce. Typically, in the independent, if you're positive to go ahead, if you like, then naturally, then in that case, you will go with one of the projects. You accept got the links, and I reckon that's the best place to look at. I mean, you've got the link, just click on it, and it takes you straight to the you know, there's a piece and platform link that you can click on, and it just takes you right in there. Make sure you use your Monash email when you do that. Okay. So it's due Friday. I'll post it in the chat as well. Due Friday, because I'm not getting any reply from you. I don't know if you hear me or not, but anyways, here. Next quiz. So Friday, 21st of August. And it's 11:55, guys, so that's quiz due. Alright, so yeah, just have a look at, I'll just punch it in here as well, so Moodle, and then just schedule. I think, guys, that's probably the best place to have a look at it, and just take a screenshot of it or whatever, put it in your phone. But essentially, yeah, that's a good way to look at it. Alright, let's have a look at question 3. Did anyone have a go at this? And I might even do it in a spreadsheet. It's a long, if we have a look at what this is, the development project involves purchasing a home and land for 15 million. The local council wants a 4 million fee, and there is a 1 million lease of the equipment. Okay. Now, the project provides a series of cash flows, and because the project is risky, you apply a discount rate of 23%. Let's calculate the NPV and the IRR, or in the second part of the question, let's use a discount rate of 10%. Now, first things first, what is our initial cash outflow? What is our year 0 or time 0 cash outflow? $20 million, right? Well done. Okay. So if we think about it, we've got all of the things that are given to us. So we've got the equipment, we've got the fee, we've got the land package, right? So naturally, all of those constitute year 0. So the cash flow leaves us then, okay? And we have cash flows for each year, right? So we've got, you know, 1.5 in year 1, then 3.27 in year 2, and so on and so forth, okay? So what I'm going to do is, I'm just going to do this in a spreadsheet. So let me just set it up in a way that we can sort of make sense of it. So I'm going to share my screen with you. Can you all see my screen? So we've got our timeline here, okay? So we've got a timeline where year 0 is 20,000, and then each year we make some sort of amount. So we go from 1.5 to 3.2, 5, 6, and it takes off. So typically, and this is a pretty realistic projection in the sense that at some point those cash flows, they do taper off. Like you're not going to grow on forever, and so on and so forth. Now the question is, well, the discount rate here is what was it, 23%, 23%. And the question is asking us, well, what do you reckon the net present value is and the IRR? So I'm going to give you, let's say, a minute to let me know what the net present value and the IRR is for the following. So let's try, everyone. Let's try and have a go at answering the question. It doesn't matter if you get it wrong. I'd rather spend longer on the questions and everyone be like, yeah, I totally get it, than just rush through a dozen questions and then everyone feeling like, what just happened? So give yourself a sec. Yep, we've got answers coming in. I want you all to get involved. Yep, so far so good. Yep. So far so good. Well done, guys. All right. All right, so I'm going to do it as well. So I'm seeing a lot of people getting the correct answer. So how do we get, I'm going to zoom in this a bit so people can see. How do we calculate the net present value inside a spreadsheet, right? So we do have a function called NPV, net present value. It returns the net present value of an investment based on a discount rate and a series of cash flows, okay, positive and negative. We can open up the bracket, read the syntax. It tells you here you need the interest rate, you need the discount rate, which is 23%. And then you want to do the values. Now, one thing to keep in mind is that, and again, why does Excel do it? Weird, don't know. I think it's generally because it actually discounts all the cash flows. Remember, the year zero cash flow doesn't get discounted. You can see it in the formula as well. But what we want here, the value one is from year one onwards, right? So the first, from year one to year 20 are the values that we want. So all I've done here is going, all right, you know what? 1, 2, 3, 4, 5, 6, 7, 8, all the way to year 20. I'm selecting all of the cash flows from year 1 to year 20. I'm going to close the brackets, okay? And then outside of the brackets, right, outside of the brackets, where I am, I'm going to go add the initial year times zero cash flow. Because remember, that's still a cash flow, it's just that we don't discount it. It's already discounted, right? And you're going to get 6 million, negative 6,533,019. All right, so naturally, net present value is less than zero, NPV less than zero. So let's go here with decision. Decision. Given NPV less than zero, we go ahead and reject. Now, to calculate the IRR, literally all we need to do is type in IRR into the syntax. It gives you the internal rate of return, right? So you open the brackets, you select all of the cash flows this time. So there's no, like with IRR, all we need is just all of the cash flows, close the brackets and click enter, right? We can probably expand that a little bit. So the IRR is a little bit different in the sense that when you do that, you literally select all of the cash flows that you need rather than, hey, this one goes, this one doesn't, blah blah blah. Like, no, just select all the cash flows, type in the formula, and you're done. Any questions? Now, in the second part of the question, you'll find that it wants 10%. So I'm just going to go here, paste what I have, just to speed up the process. And you'll find that if you're using a lower discount rate, right? Now the IR here is, decision for the IR is less than the discount rate, less than the discount rate. So we reject. And here we go the opposite, okay? Except because the net present value is greater than zero, it's 5.5 million, and here we also accept because it's greater than discount rate. So discount rate is a reflection of the riskiness of the project, and you might, if we read the question back again, you'll find that we assume two different discount rates. Now it is an assumption, right? And we'll talk about how we come about later classes, how the discount rate gets computed. But in this case here, when we use a bigger discount rate, what it does mathematically is the denominator in the formula is larger, right? So if you think about our sort of net present value formula, the number that we divide with, when it is larger, the ending result has to be smaller. And that's what we sort of demonstrated here. So if I use the following formulae, right, as we increase the denominator, this little r in the brackets, we divide by the bigger number. And therefore, the ending result, what we saw in the net present value, when you divide by a larger number, you divide by 2, divide by 5, divide by 10, that final result, the net present value, gets smaller, which is what we captured here. Any questions? One to 10, how do people feel so far? One, I have no idea what I just heard, and 10, yep, I have to do it on my own. 7s, 8s, yep. All right, good stuff. 4. Do you have any questions? If you're sitting on a 4, like, is there anything that sticks out for you? 8, yep. Different answer, okay? That's all right. If you got a different answer, that's cool. I mean, it's nice time to make mistakes. So if you got any questions, you can ask us afterwards or during the break as well. But try and replicate this. You know, maybe take a screenshot or whatever. Maybe I'll have to need to look at your spreadsheet to see why you got a different answer. Maybe your cash flows might be different. But if you got this formulae correctly, you know, in place, then just fix the cash flows and you should be fine. So it doesn't necessarily mean that you're wrong. It just might mean that the numbers that you're using might not be the same as what we got in the question, because there are 20 different cash flows given. So if you want, I can have a look at your spreadsheet during the break. All right, let's get into it, guys. The next question. So I'll give you 2 minutes in this one. An investor has a budget of 35 million. He can invest in the 4-year project shown above. The cost of capital is 8%. What investment should you make? So what we've got here is essentially 4 different projects, right? So we've got 4 different projects. Initial investment 35, 19, 15, 20. That's all good, okay? And essentially what we've got here is annual cash flows. Now remember, with this question here, these are 4-year projects. So in other words, if I look at Project A has an initial cash flow of negative 35, then it's got 4 years worth of $14 million cash flows, right? That's Project A. Project B has 19 mil initial cash flow, Project B, and then it's got 7 mil 4 years worth of cash flows. Project C is 15 and 7, and Project D is 20 and 10 and a half. Now the question here is, well, you've got a budget of 35 million. So in other words, you can't just splash out like, yeah, I'll go with all the projects. Like, there is what's called a capital constraint. You're constrained by the budget given to you on which project to select. So what do we need to do here? The first thing that we want to do is, naturally, let's calculate the net present value of each project. So let's do that first. Let's do the NPV of A, B, C, and D. And then we're going to go ahead. So step 1, net present value. Step 2, the profitability index. Now, profitability index takes your whatever present value you've got. So, you know, let's say, you know, you get whatever you get out of it, doesn't really matter. And it divides the initial investment. So in Project A, for example, that's 35 mil, right? In Project A, that's 35 mil. In Project B, that's 19 mil. So it takes the net present value from step 1 and it divides it by the initial investment given to you in year 0. That's the initial investment. And then step 3 is choose the highest choose the highest, but keep in mind that you've got 35 mil limitation. So you might be able to do multiple projects, or maybe you might be able to do one only. So choose the highest PI, okay? So those are the three steps. So let's get the net present value first, and then we can go ahead, calculate the profitability index, and then we can go ahead and calculate and choose the one that's the highest, or you can rank them highest to lowest. So go from highest to lowest. So from highest to lowest, and then we can see which one fits best. Yeah, well done. Well done. So project D and C. So let's have a look. How do we get that? So let's figure out what the net present value is. So what I've got here is the projects. So project 1, 2, 3, 4, and 5. That is, A, B, C, and D. And we've got the timeline here, right? So remember, we've got initial investment for each project, and then we've got our cash flows for each year. Okay? So if I go net present value, open the bracket, the discount rate is 8%. So that's given to me in the question. And then I've got my cash flows plus my initial investment. Okay, so we've got those that we've selected. Okay, so um, $11, $4, $8, and $14. Now let's have a look at the profitability index. Now profitability index, if I pull out the formula sheet, and it's already given to us in the formula sheet, but I'm just going to put it here so we've got it. In the profitability index formula, we can see that it's the net present value, that's what we've got, divided by resources consumed. So let's have a look at the first one. So I've got the net present value of 11, and I've got 35 mil that's been consumed. So 0.32 or 32 is the profitability index for project A. And we can drag that across, so grab the little cursor on the bottom and drag it across, and we can calculate for each of the project what the lowest, highest profitability index. Now remember, this is a profitability index. You want the project that gives you the highest profit per dollar invested, right? So if I invest $1 and I make 22 cents, like in option B, versus if I invest $1 and I make 74 cents, which one do you reckon I'm going to go with? Yeah, so we go with the highest, right? So if we rank them, let's have a look. So we already put the answer in the chat. Project D, 74. So rank it. So that's number one. Project C, 55. That's number two. Project A, 32. That's number three. And Project B, 22 cents. That's option 4. Now, which project would you select based on both the profitability index and the 35 million constraint? Because remember, while all of the projects give you a positive PI, you've got a capital constraint. You only have 35 million to invest. So let's have a look at option D and see which are highest. Project D is 20 million. Project C is 15 million. How much is that? That's 35 mil, right? It's all the same actually, I just dragged them across. Can you see the formula text? So it's this essentially. So option one and option two is what we would select. So sorry, option C and D. So choose C and D as highest PI and within 35. Yeah, budget within 35 million budget. PI, guys, is just, let me just bring that down. So that's NPV formula, and PI is just literally taking the formula. So it takes the net present value and it divides it by the initial investment. Can you see that? So we take the net present value, so this and this. Let me color code it differently. That's your PI. So you take the net present value and you divide it by the initial investment. How do we feel about this? Eight, seven, good. All right. Did you figure out your Excel problem, your MPV? All right, awesome. Well, let us know if you got any questions. Let's jump for a 5-minute break or a 3-minute break or whatever Hashem feels like giving you guys, and then we can come back and resume. You can use the absolute function if you want for the PI, but typically because you got investment, it will always be negative. You can keep it as negative, but you just need to make sure you interpret it correctly. I generally just go with positive. So I take the positive MPV and I divide by the initial investment. All right.
Yeah, let's just take 5 minutes break and then we'll continue the second half. Yeah.
We'll resume.
You want to see the IRR function? What do you mean by that? You want to see the function or the solution to one specific question? The IRR function, you just call IRR from Excel, and then you put all the cash flows into the IRR, and that's it. That's the IRR function. If you got any specific questions, yeah, I'm not sure. So I think probably question 3, is that why you use IRR? I think that's it. Yeah, basically you just apply the IRR function. You use IRR, then you put all the cash flows into the IRR function. Yeah, then that's it. Yeah, so just make sure that if you are going to use Excel to calculate IRR or NPV, make sure you have all the cash flows in Excel already so that you can put them into the function. Okay, hello everyone. Welcome back. So let's continue the class. And we still got 3 more questions to finish. And first, let's just go through question 5. So this one is the same brand mentioned at the beginning. So sometimes we got some projects and they have different lives. So they have different durations. So like the question here. So in the question here, it says you are going to have 2 projects. So the first project is called Project S, and it takes 2 years to finish the Project S. And the Project L, it takes 4 years. And another very important information in this question is that these projects can be repeated in the future. So which means after I finish Project S for the first time, I can just continue the project again. I can redo the project. And after I finish the project for the second time, I can redo it for the third time. So I can just repeat all these projects again and again. So that's the key assumption here. So which means we cannot just, we got 2 projects here. And one is 2 years, the other one is 4 years. We cannot just simply say, well, which one can give me the highest NPV? Because it will not be a fair comparison. If a project L gives you a higher NPV, probably it's just because project L takes 4 years instead of 2 years. And if I'm going to repeat project S for a couple of times, maybe I can generate a higher return, a higher NPV. So this is the problem we have here, and this is the problem we have in practice. When you are given different projects, they have different lives, they have different durations, then we need to figure out a method to give you the fair comparison between these projects. And the first part of this question is very straightforward. You are given 2 projects. We want to know what's going to be the naive NPV, what's going to be the initial NPV without replication, which means we just do not repeat these 2 projects. I just want to know what's going to be the NPV for project S if I do it for once. What's going to be the NPV for project L if I just do it for once. So this part is quite straightforward. Basically, you just apply the NPV function. So I will show you the NPV function again. You already know this from the previous questions. So basically, when you use the NPV function, the first input is always the discount rate, or the cost of capital, or interest rate, or required rate of return. It depends on which one is given in the question. Then we're going to put all these cash flows into the function. But in NPV function, the very important thing is that we can only start from CF1, which means we only put cash flows starting from 10.1 into the NPV function. And then after the NPV function, we manually add back the CF0, the initial investment. Then that's going to be the result. So I will show the formula text. And we can do exactly the same thing for project L. We use NPV, rate is still the same 10%. Then we're going to enter the cash flows, but we start from CF1, and then we add back the CF0. So this is how we use the NPV function. And just every time, after you finish the NPV function, make sure you double check your formula. So you should always see a formula, a structure like this: the NPV function, then plus back something else. So this is the structure of the NPV function. So this is the part A, the first part of this question. And after we finish this, we immediately know that project L has a higher level of NPV. So definitely here at this stage, I probably say we are going to choose project L because project L has a higher NPV, which means if I can only do this project for once, then I can get more profit from project L. But the problem here is that we can repeat the projects. This is not going to be a fair comparison. Then we need to figure out some other method to do the calculation. And here there are two methods to fix this problem, fix this issue. The first one is called EAA, equivalent annual annuity. And the second one is called as lowest common multiple. So we got two methods, but normally I will show you these two methods later. But normally we will recommend you to use the EAA method because this one is easier. This is and much convenient compared to the LCM method. Because LCM method, well, you may need to repeat the projects for many times until you have the common multiple. So I will explain these two methods later, but just keep in mind that normally we assume that you are going to use the EAA method to solve the problem. So how can we use the EAA method? What's the meaning of the EAA method? So the general idea here is that for project S, I already know that for project S, the NPV is around 4,000. That's the present value for this project. If I do this project for one time, then I can get 4,000 as a return. But the problem here is that this is just for 2 years, and this 6,000 for project L is for 4 years. It's not a fair comparison. So I figured out is there any method we can convert NPV to something like the per period, the per year form? Then I think about annuity. The general idea of EAA is like, I think I got one project, I got one annuity. And for this annuity, there will be some payment. I will draw a very straightforward timeline here. So I think about what if I got one annuity here. And if it's annuity, and this annuity takes 2 years, just as the project S, then it means I'm going to receive some PMT here, also some PMT here. That's the idea of annuity. I will receive some fixed, some constant payment in year 1 and year 2. And for these types of annuity, I will be able to calculate the present value. So definitely, I can know the present value of this annuity. Let's say if I set PMT as 1,000, then I can just apply the PV function, then I can get the present value. Now the idea of EAA is like, what if I tell you the present value? What if I just set the present value as the NPV of the project? I already know that the present value of this type of annuity is 4,132. And if we want to have one annuity with a present value as 4,000, what's gonna be the value of PMT? And then the PMT value, the value of PMT will be the EAA, the equivalent annual annuity payment. That's the general idea of EAA method. So we just think that, how about we just convert this 4,000 NPV into one annuity? And that annuity has the same level of present value, 4,132. Then we want to know what's going to be the payment, what's going to be the PMT here. Then this question becomes to the thing we learned in week 2. In week 2, we know how to use the PMT function. If we want to know what's going to be the payment of annuity, we're going to use PMT function. And we already know the rate is 10%, and we also know the emperor because we assume the annuity has the same duration as the project. Project S takes 2 years, so which means the annuity will be 2 years as well. Emperor will be 2. Present value is just present value here. And to make sure I can get a positive result, so I will set present value as a negative number, so that PMT will be positive. There is no future value, it's just a normal annuity, so no future value. Then that's it. Then now I get a result here. So what's the meaning of this result? This is the PMT. So it means that if there is one annuity, and for that annuity, it takes 2 years, and the periodic payment is 2,380, then the value, the present value of this annuity will be 4,000. And this 4,000 is the same as the present value of project S, which means I just convert project S into one annuity here. And for this annuity, the PMT is 2,380. It means we convert the NPV to something like the annual payment. The annual payment of the project S is just 2,000. And then we can just redo this process, redo these steps for project L. So this is project S, project L. So the idea is still the same. Now project L takes 4 years. So we think about what if we have one annuity and takes 4 years, the same as the project L. And this annuity will generate PMT for 4 periods. And we already know the present value of this annuity. It's just the 6,000 here. We already know the present value. Now we want to know what's going to be the PMT, what's going to be the payment for this annuity. So we apply the PMT function again. Rate still 10%, emperor, now it becomes 4. Because project L takes 4 years. Present value, we already know this, it is 6,000. Future value just 0, and then that's it. So this gonna be the value, this is gonna be the payment value for the annuity of project L. So the same idea. Now we just convert this project L into one annuity. And project L and the annuity, they have the same level of present value, which means they are equivalent. They have the same level of present value. But now we can just convert project L, the NPV of project L, into the annual payment, the annual periodic payment. And now we can just compare these two projects fairly, because we just compare these two PMT. If you invest in project S, it means every year you're going to receive 2,380 as the payment. But if you are going to invest in project L, you can only receive less than 2,000 every year. So now this becomes a fair comparison. So this is the key idea of EAA. The general idea is just we try to convert the project, or we try to convert the project NPV into annuity. And then we compare the annuity payment. And the one gives you a higher payment is the one you should invest in. Is the one is the better one. So this is how we solve the EAA and how we understand, how we interpret the method of EAA. But if you just want to memorize how to do the calculation, if you just want to memorize how to do the calculation, you do not have the formula, you do not have the formula of EAA in your formula sheet. But so if you just want to memorize this, the general idea is to NPV first. You need to calculate NPV first. Then use NPV as present value in PMT function. So this is the key idea of EAA. You just calculate NPV first. Then we use that NPV as the present value in PMT function. Then you will be able to get the result. And then you just take the one with higher PMT. Yeah, so this is just a quick summary about the EAA method. So this is the one. This is the more important one for question 5. So normally we would recommend you to use EAA to do the calculation. But what about the second method? So it's called as the lowest common multiple. What's the idea of this method? So this method is the idea of this method is easy. It's very straightforward. But sometimes if you get some very odd number, then the calculation will be very complex. So now here we just use this question as one example to show you the idea of LCM, but we are not going to use this method a lot in the future. The general idea of lowest common multiple is like, can we just repeat these two projects so that they can have the same duration? In this question, project S takes 2 years, project L takes 4 years. Then the idea is that, how about I just repeat project S for one more time? Then I just repeat project S, I do project S twice. So one project S takes 2 years, two project S takes 4 years. Then it means the duration will be the same as project L. Then I can compare these two projects. So this is the idea of lowest common multiple. But what if the number of years is not 2 years and 4 years? In this question, it's 2 years and 4 years. So it's very straightforward to get the lowest common multiple. What if one project takes 3 years, the other project takes 7 years? Then it means in total, there will be 21 years. You need to repeat the project S for 7 times, and then you repeat project L for 3 times, so that you can have the common duration, the same duration. Then this method will become very complex. So this is why we would recommend you to use the EAA method. But you need to know what is the LCM. So here I'm going to show you the idea of LCM. So I will just copy paste the cash flow here. So I already mentioned the idea. I'm going to repeat project S for one more time so that project S can take 4 years as well. So I just repeat this one. And this is the part that student can make mistake. Sometimes you may think, well, if I'm going to repeat this project, how about I just copy this and paste here? It means after the first time of project S, then I repeat this for one more time. Well, but this is the mistake. This is the common mistake. Because when you do the project S for the first time, at the end of second year, you finish the project S. And at that time point, you can immediately start this project again. So which means you should not just copy paste the cash flows after the last cash flow. Actually, the cash flow should be something like this. Oops. This will be the cash flow if you are going to repeat project S. So which means at the beginning, you just spend the initial investment. Then you receive the first cash flow. Then in the second year, you receive your second cash flow. But at the same time, you are going to start the project S again. After you finish project S, for the first time, immediately you start project S again. So this is the part you spend your initial investment again. And then you receive your first cash flow, receive your second cash flow. Then this will becomes your timeline, becomes your cash flow structure for project S. And now project S and project L, they have the same duration. So now we can just apply the NPV function. to compare which one can give you the higher level of MPV. We just apply the MPV function, same rate, value starting from CF1, and then we manually add back CF0. Then we do the same thing for a project L, and this one should be just the value here. Whoops. Because we already know the MPV of project L. So now this will be the final result. So if I repeat project S for one more time, and then the overall MPV will be more than 7,000. And then this one will be the MPV of project L, and we can know that the MPV of project S is higher. So the same conclusion as here. Same here, we use EAA, then project S can give you a higher level of PMP. So the overall conclusion is that we should choose project S instead of project L. Yeah, we got one question here. If you restart project A, no, that's not how it works. So it's like if you're going to repeat the project, then it means you need to repeat all these cash flows again. It's not just, so I think what you try to say here is that I'm going to extend the business. The business, or at the beginning, it gives me 2 years of cash inflow, but now I want to extend the cash flow. That is how you think about this. But here we say after 2 years, we just forget about the first project. It's like you purchase some equipment, and after 2 years, and that's it. And the equipment can only be used for 2 years. And after 2 years, if you want to restart project, you need to purchase another equipment so that you can do the project again. So that's the case here. So that's why you always need to have the CF0 again. Okay, so this is for question 5. Do we have any question here? Yeah, just try to just be aware that be aware this one is the most important one. Okay, 7,000. Basically, I just applied MPV function to the cash flow structure here. So here is the formula text. Similar idea. I just applied MPV function to the cash flow structure here. Okay, any other question for this one? Okay, if we are good, then we can move to the question 6. So question 6 is another very important question for this week, because this one is not just about calculation. So there will be some series, some short answer questions about question 6. I'm not saying you will see short answer question in your mid-semester test, but I'm saying that this question, this concept is not just about calculation. You need to understand what's going on here. So in the question 6, you are given 2 projects. Project 1 and project 2 both takes 5 years. That's the you got the timeline, you get the cash flows here. And the question asks you to sketch the MPV profile. And we already covered MPV profile a little bit in the Power Average section. MPV profile, X is the discount rate, is the cost of capital. Y is the net present value. So which means MPV profile, it represents the net present value for the project under different level cost of capital, under different level of discount rate. So if I use 10% as the discount rate, then I apply the MPV function, I can get one net present value for the project. But what if I change the discount rate to 20%? I can apply the function again, then I will get another MPV result. And if we get all these numbers and we draw the line here, that will become the MPV profile graph. And here we are going to draw the MPV profile. And you don't have to know how to draw it with Excel, but I will show you the plot later. And before we move to that plot, I got a couple of questions. So first one, we already know that X is just X is the discount rate, Y is MPV. Then we can have some plots, and then we just put all these plots together, then we can get the line. The first question is that is the NPV plot upward sloping or downward sloping? That's the first question. The NPV profile is upward sloping or downward sloping? Can anyone tell me this one? Someone say downward? Anyone else? So it does mean we all agree this will be the downward sloping? So the answer is that it will be the downward sloping, and this is very important in finance because NPV profile, it means the net present value given different level of cost of capital, different level of discount rate. And in finance, the key idea of valuation, the key idea of present value is to discount all the future cash flows. So which means a higher level of discount rate will make the present value lower, will make the present value smaller because you are going to discount more. So that's the first question, which means eventually you will have the NPV profile, something like this. So I already have the plot in Excel, and here are the data so that I can draw the plot. You don't have to know how to draw the plot in Excel, but I will use this one to show you some key concepts. So as I just mentioned, it's downward sloping. So if the discount rate is very low, you can see the NPV is much higher. But once we increase the discount rate a little bit, again and again, and eventually the NPV will decrease over time, decrease when we increase the level of discount rate. So this is why the NPV profile is downward sloping. And we can see this from the graph. And the second question is that because we are going to draw the NPV profile, and the question asks you to sketch the NPV profile with a pen. If you are going to sketch something, so it's very important that if you want to know a line, if you want to draw a line, so at least you need to know 2 points so that you can draw a line. If you only know 1 point, there is no way you to draw a line. But if you want to draw a line, at least you need to know 2 points. And in this NPV profile, there will be 2 points. You must be careful, you must know. If I want to, for example, let's just start with project 1 first. If I want to draw the project 1, I'm going to draw a line here, then I need to know 2 points. The first one is the one here. It's called as y-intercept, which means the point on the y-axis. And this one is another point here. I'm going to use, so this is going to be the first point I need to know. This will be the second point I need to know. As long as I know these 2 points, I can just draw a line. This one, the first one is called as y-intercept. And this one is called as x-intercept. And how can we know this point? Because the question asks you to sketch the NPV profile, you must know these 2 points so that you can have the line. So let's start with the x-intercept first. How can we know this one? What's this point? What's the meaning of this point? X-intercept, if we look this from the NPV profile, this represents what? At this point, what is the value of NPV? What's the value of NPV here at this time point? At this point, at x-intercept, what's the value of NPV? Just look into the graph. What's the NPV here? At the point here, what's the NPV? Because this is the point intercept in the x, so which means this is the point where y equal to 0. Y is NPV. So it means for this point, the x-intercept is the one with NPV as 0. So it means I change the discount rate over time. I increase the discount rate 1%, 2%, 3%, and again, until I reach some point here. And at this point, the NPV will equal to 0. And if this is the point NPV equal to 0, then what's this one? The x-intercept is called as what? How can we calculate this point? If you got the cash flow structure, you change the discount rate until NPV equal to 0. That point, that discount rate is called as what? Anyone knows this one? This is quite important. This is the definition part. It's not just about calculation. If I already have the cash flows, then I apply one discount rate, and then I use the NPV function. And then I find out that the result I can get from the NPV function is 0. What discount rate I'm using here? What's the name for that? It's called as IRR. This is the IRR, internal rate of return. What's the definition of IRR? The definition of IRR is the discount rate can make the NPV equal to 0. So it means this point, the x-intercept, it's just IRR. This is how we get the x-intercept. We use IRR function, we do the calculation, then we will be able to know this x-intercept. Then how about the y-intercept? How can we know the y-intercept? What's the meaning of this point? This point is the value of NPV. But how can we know this point? How can we find out the number here? Can we just apply the NPV function to get this one? Yes, definitely yes, because this is the NPV profile. But if I want to know this point, which discount rate I'm going to use? I'm going to use discount rate as 0, because this is from the NPV profile. When the discount rate equal to 0, then I can apply the NPV function, then eventually I will get the point here. And this, if we can apply, and if we can use discount rate as 0%, and then we apply the formula, we apply the NPV formula to get the value, then this is the one is also called as undiscounted cash flows. Because we apply discount rate as 0, which means there is no discount. We just put all these cash flows together. This is how we get the y-intercept. And after we have the y-intercept and x-intercept, then we can draw a line here. Then that will be the NPV profile. So this is how we get this figure, how we get this graph here. Then I'm going to use the Excel to show you how to get these numbers. So this is the cash flows from the question. I already put all these cash flows into the Excel. So based on what I mentioned before, there are a couple of things we can calculate. The first one is the IRR, and this one is the x-intercept. This is the x-intercept. And how can we know the IRR? It's very straightforward. We apply the IRR function, then we put all these cash flows. When we use the IRR function, we start from CF0. We just put all of them into IRR. Then we get this. This will be the IRR for project 1. Then we repeat this function. I'll just show you the formula text. We repeat this, then we can get the IRR for project 2. And we can double check this from the plot. For project 1, the IRR is 24.8%. Then we can just look back to the plot. For project 1, this point, it's just something around 24. It's exactly the number we calculate here. So it's around 24, just as the calculation here. And for project 2, it's 27%. And we can check here. Yes, this is some point here. It's around 27%. It's between 27 and 28. So this is how we get the number of x-intercept. You need to know this definition. You need to know that the x-intercept of MPV profile is just IRR. We just apply the IRR function, then we can get x-intercept. The next one, how about the y-intercept? The y-intercept, it represents the point where MPV equal to 0. So there are two ways you can get the number here. So the first one, you can just apply the MPV function. And you just set rate as 0%, because that's the definition of y-intercept. When x equal to 0, what's the value of MPV? Then you put all these cash flows, and then you plus back the CF0. Then you get the number here. That will be the y-intercept. But some of you may find out that, well, if the present value is 0, then probably I don't have to use MPV function. Probably I can just do a sum. I just sum all these cash flows. Because if I need to calculate the y-intercept, I set discount rate as 0. If discount rate is 0, which means there is no discount. So there is no time value, no discount. So I can just sum all the cash flows together. So eventually you will get the same result. So it's up to you how to do the calculation. But you need to know what's the definition of y-intercept. We also call this as net counting cash flow, which means we don't have to do any discount to these cash flows. We just do a sum to get them. And eventually you get the same number here. That will be the y-intercept. And we can repeat this so that we can get the y-intercept for project 2. Same result here. So we can double check this from the plot. For project 1, it's about 1 million. For project 2, it's about 500,000. So exactly as what we got here. For project 1, the y-intercept is around 1 million. For project 2, it's between 500,000 and 600,000. That will be the net present value. That will be the y-intercept for these two projects. Then now we know how to get the MPV profile. So this is very important. You need to understand how can we use the calculation here so that we can find out these two intercepts, x-intercept and y-intercept. And eventually we can sketch the MPV profile, sketch the MPV lines. So this is how we get MPV profile. And it's not done yet. It's just the first part of this question. The second part is quite straightforward. Is that what if we tell you that the cost of capital is just 10%? So which project you are going to choose? So if the cost of capital is 10%, we want to know which one to choose. And the question asks you to calculate the MPV. So this part is very straightforward. You already get cash flows, and we give you the discount rate as 10%. And we want to know which one has the higher level of MPV. So we just apply the MPV function. Discount rate 10%, and we select CF1 until CF5. Then we manually plus back CF0. That will be the MPV for project 1. And then we repeat this for project 2. Rate 10%, choose from CF1 to CF5, then we plus back CF0. That will be the result, that will be the MPV for these two projects. And now we got the MPV, which means we can make the conclusion. You got two projects and they are mutually exclusive, and you calculate MPV. So based on MPV, which project we should choose? Project 1 or project 2? Based on MPV here, which one we're going to choose? It will be project 1, because this one is greater. So we always, based on MPV, choose the one with higher MPV. So this is the decision rule of NPV. Based on NPV, we just choose the one with the higher NPV. So if the discount rate is 10%, I'm going to choose project 1 because it can give the higher level of NPV. But the problem here is that actually we have another decision rule about IRR. If you memorize this, we already calculate the IRR when we want to know the x-intercept. We already got the IRR here. This is the x-intercept. But based on the decision rule of IRR, which one we are going to choose? We're going to choose project 2. Because the rule of IRR is choose the one with higher IRR. Okay, so this is the key challenging part. So we got two decision rules, one for IRR, one for NPV. And if you want to make decision based on NPV, then you know that you are going to choose project 1 because it can give a higher level of NPV. But we also have the rule of IRR. And if I'm going to apply the rule of IRR, it tells me that I should choose project 2 because it gives a higher level of IRR. Then eventually, which one we should choose? The answer is that eventually we should choose project 1. And this is the first part. The first conclusion. If NPV and IRR are not consistent, choose NPV. So this is the first conclusion we can get from this question. And this is very important because sometimes if you are given two projects, two mutually exclusive projects, and after you do the calculation of IRR and NPV, you may have this scenario. These two decision rules give you the different answer. And if that's the case, we should make decision based on NPV, which means we should choose project 1. And why is that? Why we cannot use IRR? And then we can move to the plot. And I hope this plot can give you a better understanding about what's happening here. So how can we know the IRR and the NPV? So this is the IRR of project 1. This is the IRR of project 2. So definitely based on the graph, based on the NPV profile, we know that project 2 has a higher level of IRR. So based on IRR, I should choose project 2. This is what we can get from the calculation or from the NPV profile. But what's the meaning of IRR? IRR, it feels like something like a safety margin. So for example, for project 1, it's 24%. It means as long as the cost of capital, as long as the discount rate is smaller than 24%, is smaller than the IRR, this project is profitable. So this is the idea of IRR. It feels like something like the safety margin. If you have 24% as IRR, it means as long as the interest rate is smaller than 24, then it will be okay. The project will be profitable. But normally, you don't want to know the safety margin. Safety margin is not the only thing matter. We also want to know, given the current level of discount rate, whether this project is profitable or not, which one is better. And back to this question. This question says the discount rate is 10% here. If the discount rate is 10% here, we can calculate the NPV of these two projects. And based on the graph, based on the NPV profile, we know that project 1 has a higher level of NPV compared to project 2. And this is the inconsistent part. Based on NPV, we choose project 1. Based on project 2, we choose based on IRR, we choose project 2. And where is the key point here? Is a point here. And you can find out that actually between any cost of capital between 0 and 2 this point here, project 1 always has a higher level NPV compared to project 2. From 0% as discount rate until the point here, project 1 always has a higher level of NPV. But after this point, we can find out that project 2 always has a higher level of NPV compared to project 1. So which means the right-hand side, this part, IRR, this part, so probably I just tapped on the calculation. So the right-hand side, IRR and NPV, consistent. Right-hand side to this point, IRR and NPV, they will give you the same decision, the same conclusion. But the left-hand side here, IRR and NPV, inconsistent. That's the key conclusion we can get from here. We can get from the NPV profile. Then the next challenge in here is that we want to know how can we know this point and what's the name of this key point. And this one is called as crossover rate. It just as the name is the point where these two NPV lines cross over with each other. So this will be the third part of this question. We want to know what is the crossover rate and how can we calculate this. And the calculation of crossover rate is very straightforward. The idea is that we want to take the difference between these two projects. Oops. I just use project 1 minus project 2. And then we do this for all these cash flows. So now we have another cash flows. This one is called as difference. This is a difference between cash flow of project 1 and cash flow of project 2. And how can we know the crossover rate? We just apply the IRR function. All we need to do is just to apply the IRR function to the difference cash flow. Then we can get the result here. This will be the crossover rate, 20%. And I will show the formula text. So it's just the IRR function. And this will be the key point in the graph. This is point, which means now it's not right-hand side, it's not left-hand side. We can just make the formal conclusion. Cost of capital greater than crossover rate. If the cost of capital is greater than crossover rate, IRR and NPV, they are consistent. So it doesn't matter which you choose. But what if cost of capital smaller than crossover rate? Then IRR and NPV, they will give you the inconsistent result. And then we should choose NPV under this case. If these two conclusions, they give you the different conclusion, then we should choose NPV. And this is how we use the crossover rate. So for this question, it's very important that you can understand what is the crossover rate and what's the key implication of crossover rate. And here are the conclusions. So I already summarized the conclusion here. And besides the theory, the concept part, you also need to know how to calculate the crossover rate in Excel. You just use the IRR function and apply the IRR function to the difference cash flow. And then that's it. This is about NPV profile, and this one is quite important because it's not just about calculation. And you must understand what's the meaning of x-intercept, what is the meaning of y-intercept, and also how can we interpret the crossover rate. So this is for question 6. Do we have any question for this one? Or is there any formula you want me to show? Okay, so if you have no question with the crossover rate, then we got one more question to finish. So this one, question 7. So this one is not challenging at all. So this one, after you finish the cash flow, after you finish the timeline, after you identify the cash flows, the calculation part of this question is very straightforward. And you can apply the NPV function to do the calculation to get the present value. But the more challenging part of this question is you need to identify the cash flows. Because in these questions, all this information, they are not given very straightforward. So I will just go through the cash flows with you and go through the timelines, then you can do the calculation by yourself after you finish the class. So the question says, the Chloe was paid 11 million advance to write a book, and the book took 1 year to finish. And in the time she spent writing, she could have been paid to give a speech. And if based on that, the money she can earn from giving a speech will be 8 million over the year she spent writing the book. So this is the first part you need to understand. So it says Chloe was paid 11 million advance to write a book, and the book took 1 year to write. So it means if I'm going to draw a timeline here, Chloe, she will receive a cash inflow as 11 million here. That will be the cash inflow, 11 million at the very beginning, because she will receive the 11 million advance to write a book. And after she receives this 11 million, she's going to spend 1 year to finish the writing. And at the same time, what's this 8 million? It says that if Chloe, she chooses not to do the writing, if she do not write the book, she can earn 8 million for giving speech. So this will be called as opportunity cost. So this will be a cost, which means that it's not something she actually loses because she don't have to pay 8 million to other people. But this is the opportunity cost to Chloe. Because if she chooses not to write the book, she can receive this 8 million. So this is called as opportunity cost. And we need to consider opportunity cost into the cash flows when we do the calculation. And you will learn more details about this in next week when we teach you how to do the cash flow table. So here, the 8 million will become a cost. It's the opportunity cost. It feels like a cash outflow. So even though she don't have to pay this 8 million, but she cannot receive this 8 million because she wants to write the book. So it will become a cost. And after that, in the second paragraph, it says once the book is finished, it's expected to immediately generate the royalties of 5 million in the first year, paid at the end of the year. So which means after 1 year, after she finishes writing, she can receive 5 million immediately as the royalties. And it says in the first year paid at the end of the year, which represents 10.1. So this is also a cash inflow, or we can just call this as royalty. Then the next part, it says the royalties are expected to decrease by 40% per year in perpetuity. So which means in the second year, she will receive royalty again, but the value of the royalty will decrease by 40%. How can we interpret this information? And we already know that this will become a perpetuity. How can we use this? We can just treat this as a gross perpetuity. So normally, from last week, when we have a gross perpetuity, we say, well, if the growth rate is 5% and it lasts forever, we treat this as a gross perpetuity and set growth rate as 5%. In this question, we can also treat this one as a gross perpetuity. But the growth rate is a negative 40%. Which means the same story here. This is still a perpetuity. But instead of growing over time, it is decreasing over time. And the decrease rate is 40%. So we can think this as the growth rate as a negative 40%. Then it means we can just treat this part as another growth perpetuity. And if it's growth perpetuity, we can apply the formula of growth perpetuity. So this is also another tricky part. And if that's the case, then I can apply the formula, then I will be able to know the value of the value of the royalty, then in the second year, it should be equal to 5% times 1 plus a negative growth rate. Which means next year, the royalty will decrease from 5 million to 3 million, decrease by 40%. It becomes 3 million next year. Then I can just repeat this, and I can know the value in year 3, in year 4, and it will last forever. So once again, this becomes a perpetuity, a growth perpetuity in the future. And now this will be your timeline. So now we finish the timeline. And that's it. After you have the timeline, you know the cost of capital is 10%. We want to know what's the value of NPV. Then it will be very straightforward. So first, we can just convert all these royalties use the NPV function. Sorry, not the NPV function. Use the formula of growth perpetuity. That will be the CF1 divided by cost capital minus growth rate. So you don't have to really worry about the growth rate, whether this is positive or negative. You just set growth rate as negative 40. Then all the part you need to use growth rate, you just use several reference to choose this one. Then you will be able to get the result. Then that's it. That's the result here. So which means in total, the net present value of the royalty starting from time point 1, the value of this growth perpetuity will be 10 million. So that will be the NPV of the growth perpetuity. That will be the NPV of royalty. And now you have the final timeline. You only have 3 cash flows. 11 as a cash inflow at the beginning, 10 million as the net present value of royalty, and this negative 8 million as the opportunity cost in year 1 at 10.1. Then you can use NPV function, or you can do the discount by yourself. You can do the manual discount so that you can get the net present value. So this is how we do the calculation for question 7. So you will find out that the calculation part is very straightforward. After you have the timeline, it's very straightforward. But there are several things you need to know. You need to know how to identify all these cash flows. You need to understand this is also a growth perpetuity. You need to know that the opportunity cost is something you should include in your present value because this is opportunity cost. Even though you don't have to pay 8 million, but you actually lose 8 million because you want to write this book. And the most important thing is that after you read through the questions, you need to know what's the timing of these cash flows. So for example, you need to understand the royalty is starting from 10.1 because it says immediately in the first year, which means after the first year, immediately you will start to receive royalty. So that's why it's 10.1. Okay, so this is question 7. So I will show the final result if you want to know. The NPV, it will be this one plus the opportunity cost divided by 1 plus 10%. That will be the final result for this one. Okay, so this is all for this tutorial, all for this week. And this week we got 7 questions, and we already learned many very important valuation techniques. And hope you had a good week. And just remember that you need to finish the quiz 2, the post-class online exercise 2 by the end of this week. Okay, if you got any questions, feel free to ask. Otherwise, I will see you next week.
See everyone. Thank you.
Thank you. Yeah, if we've got no questions, then I'm going to end the Zoom and see you next week.
Yeah.
Recording